Okay. Qualitative analysis, okay, or identification. In qualitative analysis, UV visible spectroscopy can be used as a tool to identify if the analyte is pure and did not undergo decomposition. To identify if the analyte is pure and did not undergo decomposition. Qualitative analysis. For example, this technique is used for quality control of incoming raw material and for the purity check of biologically relevant compounds such as the nucleic acids, DNA, RNA. Additionally, the melting point of DNA can be determined by recording its UV visible spectrum at different temperatures. Okay. The melting point of DNA can be determined by recording its UV visible spectrum at different temperatures. Finally, by means of UV visible spectroscopy, it is possible to differentiate between saturated and unsaturated fatty acids present in olive oil, and thus to monitor its quality. So these are the points you should remember in qualitative analysis, how this UV visible spectroscopy is used for qualitative analysis. Okay. Okay, we'll now discuss this. Now we come to quantitative analysis or concentration determination. Quantitative analysis or concentration determination. Quantitative analysis or concentration determination. Yes, as we discussed yesterday, Lambert's law and Beer law, and if we combine both, it becomes Lambert-Beer's law. So based on Lambert-Beer's law, the concentration of a compound in a solution can be determined quantitatively by UV visible spectroscopy. To perform that, a calibration line is first determined by measuring the absorption of several standard solutions of known concentrations. Several standard solutions of known concentration. In this way, the concentration of samples such as DNA, RNA, proteins, carbohydrates, or organic compounds can be determined. Okay. The linear relationship between absorbance and concentration of a sample opens the door for a variety of quantitative analysis. In the following table, the main applications of the Lambert's-Beer law are given. We'll see this. Okay. This concentration determination. Metal ions, for example, iron, copper, nickel. In pharma industry, water industry, food and beverages industry, and electroplating, everywhere. Metal ion, for example, iron, copper, nickel, concentrations we can identify using UV visible spectroscopy. Inorganic ions, for example, nitrate, chemical COD, chemical oxygen demand also we can determine using UV visible spectroscopy. Okay. The second one, monitoring analyte concentration versus time. Enzyme kinetics, determination of rate of catalysis in pharma industry. Determination of rate of catalysis. Glucose oxidase catalyzes the oxidation of beta D glucose by oxygen. Oxidation, see here. Oxidation and reduction of pyridine nucleotides. This also can be monitored. Then cholesterol oxidation rate by catalysis with cholesterol oxidase. This can also be done. GPO, colorimetric kinetic test for triglycerides. GPO, colorimetric kinetic test for triglycerides. So if this one or two or three points are enough, this one and this one, okay, these 3 points are enough for in monitoring analyte concentration versus time. Physical chemical parameters, we can find out physical chemical parameters also. We can find out in research and in pharma industry. This is used in research and in pharma industry. Acid dissociation constant, we can find out acid dissociation constant, pKa. We can find out complex formation constant, we can find out partition or distribution coefficient also we can find out, okay. And dissolution tests, we can do dissolution tests also. So these are the applications in quantitative analysis. These are the applications in quantitative analysis, okay. Quantitative analysis we have, okay. This is enough. Qualitative and quantitative analysis, okay. Now if you have any doubt you can ask, because